Okay, everybody, good afternoon, or if you're on my side of the country, good morning. Thank you very much for attending today. This is school-specific lighting for you guys at Spitzel Architectural Group. It's a joy working with you guys and talking a little bit about one of my passions, which is lighting and different applications of it, especially in the school setting. So today we're going through a survey level course. The goal of today's course is to give you a general understanding of some of the different utilizations of light inside of a school setting, specifically K to 12. Public or private or alternative will function just as well here. This is not a webinar to go into the weeds. We do have other webinars where we do that, and I'll show you a few of those, which can be scheduled at a future date if you'd like to. And we'll leave some time for Q&A at the end as well. If anything is asked that's beyond my scope, then I'll connect you with someone on the team that'll be able to talk shop with you a little bit deeper afterwards. All right, so let's start to drill in. So my name is Dan Lippin. I am co-founder and president here at Pure Lighting Company. And among my responsibilities, all of us wear many hats, as all of you likely do as well, is educational outreach. For us, knowledge is power, partnerships are power as well. And so it's a great opportunity to be able to chat with you again this afternoon, going over this and hopefully bringing in a little bit of insight on some different types of lighting solutions that can be offered, or at least provide a little bit of inspiration. My background is in electrical and computer engineering, graduate from Rutgers University in, I think, all of our home states of New Jersey, and am a member of many lighting organizations, as you'll learn from our company. We are across stage, UV, and of course, LED of general illumination lighting. And again, education is important, so I'm a presenter at conferences. I'll be presenting at USITT in March, and I have an article that'll be released in LDNA in just a few days on UVC lighting. So please check that out. Send me some feedback. Let me know what you think, and hopefully you enjoy that. All right, so as a company and where I'm coming from, we are a design dealer of science-based human-centric lighting solutions. We do have a specialty in school settings, and you'll hear a very big bend on human-centric lighting. I deeply believe that our institutions, our facilities need to provide not only safety, not only comfort, not only function, but need to bring out our best. And I think in the wake of a world-closing, world-shattering pandemic, we've learned what a good facility can be and what a standard or subpar facility can be. Again, we have 3 branches: LED, which is our general illumination, stage, theater, stages, TV broadcasting studios, and UVC, disinfection, germicidal lighting. We'll actually touch on all 3 as we go through today, because all 3 interact with schools. All right, and then I mentioned too, in terms of AIA courses, today is a survey level course. Big brush strokes, big picture. That's all we're sticking with today. I don't want to dive in too much. This does make it a all levels type of webinar. If you do want to get into the weeds, this is a selection of courses that we offer: UVC disinfection, stage and theater lighting for schools, and wireless lighting controls. I will talk a little bit about those, but there is so much potential and so much happening in the world of lighting controls right now that I'm excited to be part of this industry and moving it hopefully a little bit forward, just as all of you are. All right, and last thing, last PSA before we start to dive in. If you have any questions at any point, I ask that you put it in the Q&A module that's built into Zoom. If you put into chat, it makes it a little bit harder to see, especially if a few people are chatting at the same time. So use that Q&A module, add a question at any point, and they will be addressed at the end of the webinar. All right, so let's start to dive in and start talking about the needs of the schools of tomorrow, or we should rather say the schools of today, right away. So what are we looking at? we have a time where there is let's say a little bit of a paradigm shift in the way we're looking at our facilities and in the way that we're looking at what it means to be a safe, successful school, especially considering the consistent rise in enrollment to alternative education, whether that's going to be um, alternative schools like Montessori schools, or that's going to be full-on homeschooling or home-based schooling programs. Now for schools, again, public schools, that's going to, their enrollment is directly influencing the taxes that they're getting and therefore the budgets that they have. And obviously for private schools, what they're able to offer to their students, to their communities, to their parents directly impacts what kind of enrollment and whether they do or die, survive, or thrive. And so we want to make sure that the facilities that these schools have are going to be the best possible facilities to be able to go and encourage students to come into school, to encourage staff to feel safe and not report high levels of absenteeism, and to make sure that parents feel safe sending their kids to those schools. So again, some of the major points we want to go and address here is going to be safety. We do have a terrifying uptick in school violence, and this is going to be overt and implicit. And so we'll find ways that lighting can go and reduce violent gun crime, as well as crazy as it sounds, hate crime as well. We need to make sure that our schools are built on sustainable, eco-friendly ground. With LED lighting, we've already taken huge steps in reducing our carbon footprint, but there's still a little bit more that we can do by maximizing our lighting techniques and also making sure that we're using the most modern technology. We need to make sure that our facilities are healthy. This is something that we might have not thought about too much before the pandemic, but the pandemic has shown a light in terms of how pathogens spread in areas of highly contained people. Schools are nexus points for communities. Students are coming in from all over a town, all over a district, coming back to their parents are going to their offices, spreading these pathogens. So any of our high traffic areas do need to make sure that the indoor air quality is going to be high so that people are comfortable in the building, and also reduce as much as is available pathogen spread. For schools, interactive. I think that we all know, and we have probably all sorts of learning types on this webinar. We have those that probably thrived in our math and science classes, those that thrived in our more artistic classes, those are a little bit more kinesthetic and hands-on and tactile, and those that are a little bit more theory-based, and thrived doing math problems on the chalkboard. So we want to make sure that schools provide opportunity for different types of students, and that interactivity is something that we can achieve with some of our lighting technologies, especially when we start to look at our TV broadcasting studio, we look at our auditoriums, and we start to look at our STEAM labs, aka increasingly our media centers. And then finally, inclusivity. We know the importance. We know that our country is built on diversity, and we know, some of the terrors that we've had in the past few years, bringing some of our maybe our nation's unsavory past kind of to light. And so our schools are our future. Our students are our future. And so we need to make sure that our schools are going to be as inclusive as possible. And again, it's going to be inclusive not only of creed, gender identity, orientation, but we want to talk about ability, physical and mental ability. We want to talk about learning style. We want to talk about socioeconomic background. And again, it sounds a little bit strange. We'll start to touch base there, that the way that we light and build facilities can have a direct impact on how people feel comfortable, safe, and inclusive in a school setting. So now that we want big picture, let's start to dive in a little bit and make a plan of attack for how we're going to start to address some of these issues. So we're going to talk about 4 major aspects of lighting. We're going to go into general illumination and architectural design. This is honestly going to be a place where I'm going to be repeating a lot of what you know, but just reminders, hopefully to go and encourage the best design and also maybe to set you free a little bit in terms of how you look at designing schools. Seeing that school design can be just as beautiful, aesthetically pleasing, and involved as designing a modern corporate outfit. We're going to talk about UVC disinfection solutions, especially facility-wide solutions for a place like a school. We're going to go into some specialty lighting systems. Those are going to be our auditorium, theater, TV broadcasting studio, media center, STEAM lab. And we'll talk about some emerging trends to keep an eye on for some of the new constructions and major renovations that you might be working on now or in the upcoming few years for some of these school clients. All right, so the difference light makes. As you may or may not know, light is so much more than illumination. Our bodies depend on the light of the sun to kickstart our circadian rhythms. Our circadian rhythms are going to affect things from our hormone secretion, affecting cortisol, affecting indirectly our organ functioning, to the way that we focus, to the way that we exist, the way that we interact, the way that we feel safe, the way that we feel comfortable, the way that we're seen, and the way that we see. So lighting is science-backed, showing there is a high level of importance. And we can take some of the information, some of the data that we're getting, some of the new research that we're looking at, and see how we can start to incorporate that into our buildings. Right. And so we have a few things that we know. We know that in this time, we've had high levels of absenteeism, and this is not just students, it's actually perhaps more damaging is going to be teacher and staff absenteeism. So how can we use light to go and support spaces that staff and students feel more comfortable and safe? Lighting can go and make more equitable spaces, can make safe and welcoming spaces, can make spaces where people are seen and feel seen. And lighting can allow spaces to be used in a myriad of ways in school facilities that don't change, but have many evolving needs. We need to make sure that our spaces are built in ways that can adapt to whatever need is thrown at it. And so when we're looking at our considerations of lighting, again, some of our basics, but a lot of times it is going back to our basics to make sure that we are providing the best that we can provide. You know, I think that's the athlete motto every off season is just going back to the bases. I'm a big hockey fan, and it seems like the hockey players are always just working on their skating stride or working on their shot all summer long. And I think we can do the same in our professions, just tap back into the basics. So we look at color temperature. We have our higher CCTs, and at those higher CCTs, what we used to think was all LED back in the day, we do get some effects. We have enhanced focus and concentration. A bluer light is going to kickstart cortisol in our bodies. So in the morning, a bright dose of blue light is actually going to have a similar effect to coffee. Not going to ditch my coffee quite yet, but it still is highly effective on that side. So when we are looking at testing, when we're looking at active learning, bluer light is going to have a better effect. On the flip side, blue light can cause anxiety, can cause hyperactivity. And so when we're looking at maybe our special needs classrooms, blue light might not be so effective. It can be a little bit triggering, especially when we have students that might have autism. And so in that case, a warmer light is going to be effective in some of these areas. So low CCT, relaxation, calmness. This might be better in some of our spaces where we are trying to ground and root down. So if we have a pre-K elementary school, maybe it's something that's nice to have for nap time. Maybe this is nice for some of our certain areas where we do want to have a little bit of that calming grounding effect. So it is something we do want to be able to incorporate into our technology. Again, too much of this, sleepiness and lethargy. So we do if we have to pick one color, we do want to go a little bit brighter throughout a school facility, but don't want to deny the warmth. But fortunately, we have color tuning technology, whether it's just built into whatever flat panel, pendant, whatever we're putting in, or more fun, we have lighting controls that can either adjust based on circadian rhythm, can also base on photosensors to go and automatically adjust the light based on the time of day, and allow also a little bit of training for staff so they know how to utilize the light to have a direct effect on their students. All right, next up, brightness. You know, something I was reading not too long ago is that apparently, and you guys can probably talk to me a little bit better about this because I know the North American market, I don't really know the European market, but apparently we have a little flair for brightness here in the States. But still, you know, I think that provides a little bit of our productivity, and that's what science will show. Again, bright light is something that is going to have a direct impact on the body. Natural sunlight is going to be about 10 to 100 times brighter than our typical indoor illumination. And so when we're spending the majority of our time inside, especially in the morning, we're not getting that, again, that cortisol release. We're not getting that proper, you know, signaling from the sun. And so providing bright spaces is going to have a good positive effect. Again, because schools are operating throughout the day, it is something that we want to make sure that we do have bright spaces inside of our classrooms. That said, we are incredibly attuned to differences in brightness. And so if we have a space, let's say the hallway, which is a little bit brighter than our classrooms, we're going to adjust to that and it's going to look far brighter. Using contrast is going to be important to focus brightness on our work planes. So classrooms themselves should be brighter than hallways. I think it's something that's obvious enough. And when we have that effect of brightness and the energetic effect of it, then we have some of our neutral places, like such as our cafeterias, which don't need that high level of brightness unless we have a certain function going on. Fortunately, we have usually our LED high bays in those classrooms that blast so much light that we have not enough light is rarely a problem there in our modern implementations. And then finally, we'll talk a little more about it in just a moment. Daylighting is something that we can do as an eco-friendly practice. Also, the sun's light, we'll talk about this later as well, has a much larger spectrum than our typical LED lights. And it starts to get into places such as infrared lighting, and again, different colors that are built into there that are going to have different effects in the body. So there's nothing like sunlight. Sunlight is going to be the healthiest source of light. So allowing in natural light, and even if we're looking for a scientific solution, we can equip classrooms and areas with photosensors to naturally raise the indoor lighting to go and match whatever foot candle or lumen output we want to get inside of that classroom. All right, and then finally here, glare and flicker. Glare itself, yes, we have our obvious glare like you see in this picture, but we're also going to have the glare that emanates off of our very smooth desks, whiteboards, and also just from the light fixtures themselves. Glare can cause discomfort, difficulty seeing. Long-term eye damage has been shown, as well as headaches and migraines. So with our solutions, indirect light, so our light sources that provide a mix of uplight and downlight are going to be effective. Of course, we want to make sure that we have good quality diffusers inside of our light sources. Fortunately, we're pretty good across the board with lighting nowadays, that you don't have to make too much of a concerted effort there. And then having dimming ability. With the glare, the difference of light source to ambient lighting around it can cause that glare. And so having the ability to dim is going to reduce that as well. And then we have flicker. Flicker is going to be the natural turning on and off, the cycling of a fixture or a light source. This is something that typically happens at a much faster rate that we can visibly notice or see, though especially with our older generation LEDs, when they start to dim down, you might notice that. Flicker itself causes headache, eye strain, can induce seizures in some cases in people that are predetermined towards that, and then can also cause and trigger migraines as well. So when we're talking about human-centric schools and facilities, trying to use flicker-free sources or low flicker sources, there isn't a great way to test other than very simple ways. Grabbing your phone. If you have one of those modern Androids or iPhones, you have a option for a few different frames per second. Take some little recordings, and if you're getting that flicker effect, then you have a high flicker light source. Again, fortunately, solid state lighting is moving away from that. Most higher and medium end LED lamps, whether it's a T8, A19, or just a built-in fixture, are going to be moving away. Also making sure that you're using compatible and high-end dimming, and that those light sources have drivers that can go and handle those dimming protocols. 0 to 10 dimming is going to be effective. Flicker does tend to come hand in hand when we're dimming LEDs through line voltage. Again, that is a residential solution that we want to avoid inside of our commercial facilities. All right, and some green practices that we can look at. Again, we mentioned green schools, eco-friendly schools. If we want to be, let's say, not as altruistic to our planet, let's at least think about the purse strings of tight budgeted schools here and lower their electrical bills. So modernizing LEDs. So we're at a point where it's about time to start to look at upgrading from first generation LED. So if you're looking at LED sources from 2015 and around 2014, 2015 is when we had that crazy hockey stick effect where LED became mainstream and price went down to a reasonable amount. That generation versus now, we're getting about 50%, 50% better efficiency now than we did then. So we can expect significant savings across the board by upgrading LED. And modern LEDs, as we mentioned before, better dimming. They're going to be able to get much lower. If you remember, older LEDs had trouble at around the 10% dimming capacity. We're not going to have as much of the flicker, and we just have much more controllability with modern LEDs. So that's going to be something to look at. Next up, daylighting. Again, having our windows, having ability to allow natural light to enter facilities. Of course, mitigating through shading and window treatments. Those are things that you know a billion times better than I do. But in terms of lighting, as mentioned before, we can put in photo sensors to go and naturally, or automatically, I should say, find a standard of lighting that we want in those rooms and automatically adjust the lighting to match that. If we want to get crazy and the technology is out there, we can mix circadian lighting, color tuning, and photo sensors with daylighting to match the natural color of the light coming through inside of our classrooms. Don't think it's necessary, but it's something that's out there if you want to go dive off the deep end. And then finally, occupancy-based controls. This is something that's often used. We see them in hallways a lot, but the technology is improving more and more. And as we dive more into IoT-based systems, we'll talk about that a little bit later, there's just more opportunity to have a wider array of sensors that are going to provide the data that we need to make sure that lights aren't turning on or off while places are occupied, but do allow for savings by keeping our lights off or low when they don't need to be on. One thing that's interesting is when we're looking at linear dimming. So dimming, there's linear and logarithmic. Logarithmic is going to provide a much more natural curve as we move the dial up or down. But when we look at linear dimming, our eyes aren't really that great at discerning the difference from around 50, 60% to 100% brightness. So even moving down to that 50% brightness in that bi-level dimming, we're still going to get pretty significant light output and be able to save pretty significantly on electrical bills. All right, let's start to one more thing with general illumination. Again, lighting for safety. When we talk about safety, in terms of crime, it's colloquial and it's data-driven. Bright, well-lit spaces are going to reduce criminal activity. So especially in our outdoor areas, making sure that we have adequate brightness. I know a lot of our school facilities are built with neighbors next door, so we don't want to be shining bright wall packs into the kitchens or living rooms of the neighbors next door. So that's where we have cutoffs. We can use sensors and all sorts of sensors between timers to trigger lights off. We have sensors where we can go and have the motion sensors. That little step up that we get when the sensor clicks on, whether it's from on to off or 20% brightness to 100% brightness, acts as a deterrent. We have IoT implementation. So something that we see as technology emerging is going to be light poles equipped with cameras. And whether it's just that directly or there's sensors involved which indicate when motion is there to ping, hey, we have something on camera here, or even to produce some sort of effect, whether it is calling 911 or it is changing the color temperature or color full on the color of the light. We can do all sorts of creative things as, again, a deterrent. And then vandal resistant fixtures where need be. I know we were working with Newark Public Schools, and we had one school in a not great area where they, the light fixture that existed kept on breaking in a way that you might expect or might not expect, and it took a heavy duty vandal resistant fixture to transform that corner away from a place where they're dealing in wares that they shouldn't have been dealing with. Let's just put it that way. And then finally, it's not clearly written here, but also, again, it was mentioned before, bright, well-lit spaces indoors as well are just going to provide a little bit of a safer area. There have been some studies shown where good lighting design on that side can reduce bullying by providing less areas where bullies can feel like they can do something unseen. All right, so let's start to shift gears a little bit. And just the last bit of encouragement here. Again, research science shows beautiful places have a lot to offer. Students, staff feel more comfortable. Communities have a greater sense of ownership. And just having a beautiful area provides a greater sense of welcoming and openness. And there's been data showing that well-designed facilities, especially school facilities, do provide greater opportunities for diverse audiences. And so on that way, please go to town, please dream big, please be creative with your design. It's hard to find examples of classrooms that go outside of the norm of exactly what we think about with a classroom, whether it's our standard 2x2 or 2x4 panels, or at least now we have our suspended linear fixtures. But I think that there's much left to do in terms of design and ability to collaborate and use those spaces, flex spaces. So again, I love what I see from you guys. I had a very fun time going through your website, and I hope that we can use science as proof and backup to go and do some really creative work going forward. Okay, so let's take a little bit of a turn. And I do this as I have to blow my nose. So I guess that's as good of a transition here as we're going to get. Indoor air quality. Something that we might have not talked too much about 3 years ago. There have been standards, the WELL standard, for example, which was started in the early 2010s. has been adamant about this for quite a while now. It's something that we've had some niche applications with, but now that we've had a global pandemic shine a light on some of the inefficiencies on our indoor safety, it's something we need to look a little more seriously about. So with lighting, we have UV light, which has an ability to disinfect against a slew of pathogens, as well as reduce VOCs and even some chemical residue. It really is amazing what the spectrum of lighting can do. Now, in terms of utilizing it, we have inside of our schools pollution and VOCs, especially in a urbanizing world. Again, I know a lot of you are based in New Jersey, which is, at last check, the most densely populated state in the country, inside of the metro area of both Philadelphia and New York, and not too far off from DC and Boston. So we have a lot of urban centers in those areas. Pollution and VOCs creep into the room, especially to a point where opening the window isn't going to be a sufficient way of providing fresh, clean air. Allergens inside of our more rural and suburban areas, especially in the springtime and autumn, are going to have direct effects on respiratory systems, including asthma, causing asthma, as well as eye irritation, nose irritation, ENT irritation, and could be worse depending on the student or staff member. Pathogens, I think we labored this point home over the past couple years, but again, it's not just COVID-19. We see what the flu does. We see even what the spreading of colds do, and we have inside of our medical facilities the dangers of antibacterial resistant pathogens like MRSA and C. diff. So we need to make sure that we're as proactive as possible inside of our high traffic facilities, including maybe notably schools, at reducing pathogen spread. And then even chemical byproducts. That's been a typical way of treating areas, but harsh chemicals do have harsh byproducts, especially for younger students in our pre-Ks and elementary schools. And what we've seen since the pandemic began, and there's been more usage of these chemicals, is a 60% uptick in calls to poison control centers. And the main culprit there has been the vapors and fumes associated, not accidental ingestion. And so that in of itself isn't a proper solution to just spray down. We can go and leverage technology, and we can leverage light. So when we talk about UVC, it's effective, depending on the dosage provided, can achieve up to 6 log 99.9999% reduction of a bevy of pathogens. And essentially every pathogen that's been tested has been susceptible to UVC light, just depends on the dosage. When properly implemented, UVC light is safe. For passive implementations, we'll talk about that. There's no UV light exposed. For direct applications, we can again use technology and use the technology that we know as the lighting industry. We can use sensors to go and deactivate fixtures when motion or occupancy is detected. We can use timers, scheduling functionality, and all sorts of things that we already do in our other lighting systems. UVC is future ready. As mentioned before, it's not just going to be effective against COVID-19, but it's going to be effective against the flu, colds, and all sorts of pathogens, making for safer spaces. And it's versatile. It allows for automated systems that are pretty much, install it and forget it systems. There have been, working with a lot of schools, reductions in facility team staff. And so to have manual operation of technology has been difficult to achieve right now. And so passive automated systems have been something very much in demand because otherwise the district just can't meet the need that they have. And so when we're looking at methods of delivery with UVC, 3 major ways: HVAC based, and that's either going to be in the air handling unit. A additional benefit there is going to be cleaning the coils of biofilm that develops, and that's going to improve the efficacy of the HVAC system. Honestly, any new HVAC system that's being implemented, the UV light in there isn't a very large expense, and for the energy savings that'll be accrued. Not even to talk about the pathogen reduction, I feel it's a no-brainer. It can be put in the ductwork, not as effective, just because it's going to be a little more limited in scope, or it can even be put in more locally in unit ventilators, where we are in the Northeast, or where you guys are in the Northeast. That is something that we see typically in classrooms. We have fixtures, so these are going to be installed, and now this can be a bevy of options. We have UV assisted air purification that sucks air in, uses UV light to go and disinfect, and releases out the purified air. We have upper air solutions that are going to shine light at the top quadrant of a classroom, of a auditorium, of a cafeteria, and the natural convention currents are going to provide a disinfection of the air. And we have fixtures that provide direct surface and air treatment, such as what you see in the picture there. That's actually a hybrid unit. It provides both air purification and direct purification as well. And finally, with portable solutions, I mentioned and harped a little bit before on automated solutions. It really is a great way for you and what you do. More permanent built-in solutions are going to be more interesting anyway. But portable solutions are something that are nice for spot cleaning or for budget conscious clients. So wanted to mention it to be fair there. And best practices when we're looking at UV implementations. So we have the concept of near versus far air. The closer you are to where people are occupying a space, the greater the efficacy of the system. So on that side, that fixture-based solution is going to provide better efficacy than a HVAC-based solution. An HVAC-based solution can risk some cross-contamination between classrooms, and it's just going to have too much airflow that it needs to deal with. And finally, in addition to that, it's not going to treat any of the air that's recirculating inside the classroom. So having something that's local to the source is going to be more effective because it's going to provide quicker disinfection and more efficacious disinfection. Now we have next up, occupied and non-occupied. It's important to provide disinfection for occupied spaces. Otherwise, it's honestly not that necessary. So having a, whether it's a far or near air purification source, whether it's upper air, or an air purifier is going to be important. But when places are unoccupied, a direct UV solution is going to add an extra level of, let's say, near sterilization of that room. So having a hybrid solution is going to be effective there. And then finally, I mentioned before, the dosage is going to be important. So having a simple way to recommission systems based on the dosage that needed to treat the most prevalent pathogens at the time. Also to have monitoring capabilities to understand what's been on, what's the lifespan left of a lamp, what kind of dosages have we achieved, whether this wants to be shared with community members and staff, or this is just an opportunity for the facilities team to make sure that their system is operating properly. And some emerging trends there, things that you might have come across is far UVC 222 nanometer wavelength. Incredible promise. This is safe to be under. It's been tested on all sorts of mammals, including humans. Right now, the light sources themselves are not powerful enough to provide ample disinfection for surface and air. It is, at this point, essentially an air exclusive solution, and the price does add up very quickly. Hopefully we get more efficacious solutions in the next few years. I know that far UVC LED is a way off right now. So they're working with Exmer Technologies. Hopefully they can go and continue to refine that in better ways. And then there's 405 nanometers. This technically isn't UV light. This is visible light. It has a very light germicidal effect. When it's purely on, you see this picture up top, it's that violet blue light. But the interesting factor of it is that it can be incorporated into normal LED boards and operate. So The light color itself isn't affected. So we still get that 4,000, 4,500, 3,500K light source, but there's a light germicidal effect that's going on. And when we combine that in every single light source, we do start to limit and reduce to some degree the pathogens. All right, and I'm going to shift gears one more time here. And start to go into some of our more creative areas. Theaters, auditoriums, TV studios. Some schools have their black box theaters. And this will also include for some schools that have recording studios and dance studios. Vast benefits for students. We have our soft skills, the increased empathy, communication, confidence, a whole bevy of a certain type of learning style that can feel heard, feel seen, and develop and grow. We have, in addition to that, an opportunity for very STEAM-based learning opportunities. Inside of these places, we do have the technical aspects of lighting control boards. Inside of our theaters and auditoriums, we have our sound and possibly visual aspects as well. We have the way that lighting is being affected. We have the way that sound is being transmitted. So we have real world STEAM application centers as well. And for schools, especially schools that are struggling with budget, having a modern performing arts center or having some of these modern facilities, whether it's a TV studio or a recording studio, does provide opportunity for rentals and to accrue additional revenue. We have a lot of clients that we've worked with that do actively rent out their facilities and are essentially able to bankroll their renovations and upgrades based on the money that they receive from those rentals. When looking, I have to go in here in such broad strokes because these are all very deep conversations. Again, we have a whole webinar on this, a whole AIA class. So if you want to dive in, let me know and we can schedule it. When looking at stage lighting, very important to have a proper lighting plot to make sure that we get even wash on stage, to make sure that we're able to get the proper effects that the school is looking for, whether that's going to be cyc lighting in the back or a simple 3-point lighting system. We need to make sure that we have proper rigging and we have not only tested rigging, which is code required, but we also have rigging that is going to be accessible to go and change the layout of fixtures per show. We do have motorized rigging is starting to get a little bit more cost effective, and we are starting to see that in high schools with PACs, or we can do counterweight rigging, which is the typical. Some schools do elect for more of a fixed solution, and in that case, it's nice to balance, have a little bit fixed, a little bit flying, and so you know, you can have the basic fixed that you don't have to touch very often, and you can still adjust the flying rigging. We have, in terms of the industry, moving lights are starting to become more cost effective. So in the past, the movers, which seemed that they were designated only for high-end houses, can now go into schools. And so it's something that's interesting to apply. We have other effects as well, gobos, which can be outfitted with school logos, as well as some other visual aspects such as projection, and even video walls can be utilized as well. And something else to look at is not just the stage, but how does the entire auditorium interact as well. And so we can look at some beautiful and interesting effects using RGBW lighting on the walls, on the side, incorporating that even with acoustic paneling to provide the best of you know, sound dampening, as well as a beautiful 360-degree interactive experience. In terms of house lighting is interesting because we often have sloped ceilings, and we want to make sure that we have a even wash. If you actually look at this picture here that's in the middle, This is actually not a good example of house lighting at all, because you see that there's going to be areas that are more highlighted than other areas. We want to make sure that we have an, excuse me there, an even distribution of light, and that's going to be affected by the beam angle and the wattage or light output affected from the light sources themselves. So a proper lighting plot here is necessary as well. Another thing for schools, especially that are going to have to practice social distancing for quite some time, auditoriums are perfect areas for social distance classrooms. So making sure that the lighting output is bright enough for multi-use purposes, whether it's going to be testing or as a classroom, is important. And then a smooth dimming protocol, getting down to the ability of just a little bit of light, flicker free, that 1% functionality is necessary here for house lighting, or at least properly implemented house lighting. And in terms of controls, integrated controls, one of the major things that we see inside of new auditoriums, TV studios, these types of applications, is going to be a lack of trained console operators. And because of that lack of trained console operators inside the district, this beautiful facility grows cobwebs very quickly. So inside the implementation, training and retraining is something that should be included and considered. House lighting should be accessible via both the console and wall plates, just so the auditorium can be used by anyone who might not be trained. Easy operation to maximize usage for guests. So this can be integrating in maybe like a Crestron, Extron, or AMX based system that is going to allow the lights to function through a wall panel with presets already built in, and intuitive application that's going to allow, again, anyone, any guest, anyone who's authorized to use the system without fully understanding how to use the console. And then finally, integration of AV and lighting all into that singular console. Again, broad strokes today. We can go much more into detail in the future or in the Q&A. All right, and then TV broadcasting studios. They're going to be similar in a lot of ways to our auditoriums. A few differences on the side of lighting. Flicker-free light sources are going to be necessary. The camera is unforgiving to flicker, while the eyes might not notice. Higher CRI, again, the cameras are going to reflect that much better than our eyeballs are. White balancing takes higher priority, so that means that if we have 2-3 different manufacturers that we're using, we need to make sure that 4,000 Kelvin is 4,000 Kelvin across the board. We see that oftentimes in our standard LED lighting. I don't know if any of you have had the experience of looking up at a ceiling and seeing 3 or 4 different colors that are just a little bit off from one another. While that's annoying inside of a classroom, that is an absolute no-go in a TV broadcasting studio. And then for a lot of these, I use green screens to make sure that an even wash is applied. We're going to have some different types of fixtures. While the base is very similar, barn doors are more heavily utilized inside a TV studio to go and affect the beam angle and beam direction. All right. As we're running a little bit low on time, STEAM learning, I think everyone on this webinar has benefited from STEAM learning outcomes. If you're unfamiliar with that acronym, science, technology, engineering, art, and math. It used to just be STEM, but the incorporation of the A of the art is critical here because that allows for design. Design is, again, I'm preaching to the choir. Design is not just creating pretty things. Design is functional form. So that is going to allow future architects like yourselves to enter the workforce, as well as computer program design, software design, building design, and everything that falls under. So our media centers are going to become modern STEAM labs. Some schools are going to have distinct, discrete STEAM labs, but media centers more and more are entering that space. A few things that we can do inside of those facilities to go and utilize and maximize lighting. Interactive. Having some ability for students to have control. This might be RGBW light sources with a wall panel or an app-based controller that authorized users can access. It might be a little bit of a simple lighting controller that students can go and work on programs and setting up presets and scenes and working that way. Letting the students actually interact with their environment, getting creative, getting curious, looking at things in a different way, and seeing that they can directly impact the spaces and environments around them. Modern. If we're talking about high tech, we're talking about the future, we want to create spaces that inspire that. Again, these are spaces that usually thrive with design. You know, I love flipping through photos and just looking at these beautiful implementations. So again, it's another encouraging push, get creative, do beautiful work here, have some fun with it. And then finally, functional. Letting these be spaces where students can have an opportunity to learn. So here we have a photometric report of lighting output. So even maybe having, you know, some of the design components accessible to students, and they could look at the space and understand what was the engineering, what was the math, what was the science, what was the reasoning behind building here. And again, they can get a real world practical application understanding of what went into that space. All right, and then some emerging trends we'll fly through a bit because again, I don't want to hold you past time. IoT adaptations. IoT is coming. It has such great potential. And when we look at lighting systems, especially with fixtures, so ubiquitous throughout schools, are perfect opportunities to act as major nodes of IoT-based systems. They're going to allow for safer, more secure schools. They're going to allow for better asset tracking. So if you have a couple wheelchairs in a school or some more expensive equipment, it's going to allow for better understanding where they are on campus. It's going to allow for things like automated attendance, better lighting systems in terms of occupancy, in terms of day lighting. So again, incorporating more IoT-based adaptations. Robust building management systems and AI. As we get more IoT, we're going to have to get better abilities to understand what's happening and to be able to interact from a central console for not only a facility, but a district of facilities. And incorporating the data that we receive from BMSs with machine learning is going to allow for better understanding of how facilities are used and automated functioning to go and better provide and better be able to have green practices, get lights dim when they need to be, and also just, again, provide a better opportunity for understanding that flow and function of a facility and automate as much as is possible. Health-centric lighting, we see that already starting to emerge, and the sun has so much more than just a single spectrum of light like our LED sources have. For example, sunlight is going to have a degree of infrared lighting. Infrared lighting has been shown to have healing effects on our skin. And so when we start to look at wider spectrums and we start to bring the sun indoors, we're going to have much more of a natural response to it inside of all the natural photoreceptors we have in our body to create healthier spaces. LiFi is a emerging technology, which for school applications is actually a very interesting one. So if you're unfamiliar, LiFi, it sounds like Wi-Fi because it's a very similar concept. It's the ability to access networks using frequencies inside the light rather than radio waves that wireless systems currently use. One of the reasons why this is interesting for schools is that schools tend to be very concerned with the security of their networks. And at this point, LiFi systems are more enclosed than network-based systems. So it might be an opportunity to create safer school networks and utilize the lighting in, again, a way that's beyond just illumination. Continued use of RGBW lighting. So we have the technology to incorporate RGBW lighting is becoming much more accessible for standard lighting opportunities. So of course, we can have this inside of our media centers, inside of our auditoriums. We can also start to incorporate this for other effects such as emergency egress lighting to go and, in the case of a fire drill or an active shooter drill, to be able to have lights that go and beam where students should go. In the same case, if we have an IoT system and we have RGBW lighting, we can go and have the lighting indicate areas where there might be an active intruder and where not to go, and provide, again, clear direction for students, staff, of how to navigate through a facility safely. And then finally, continued improvements to energy and controls to go and have a smaller carbon footprint inside of our facilities with better control infrastructure and more utilized controls, whether they're wireless based or more of an IoT based system. All right, so that is that. It is perfectly an hour. I will stick around for as much Q&A as anyone would like to do. If anyone has any questions that they would like to ask beyond the webinar, send us an email, info@pure-lighting.com. If anyone wants to dive into another one of the webinars, again, let me know, email us and we'll schedule it. And I will follow up this webinar with a quick email. If you want the AIA credits for attending the course, please reply back to that email with your AIA number. There'll be a little form to fill out. Otherwise, again, thank you so much for attending this afternoon, and we'll turn it over to any Q&A. Okay. Perfect. All right, so I just have one question right here, and it's a little bit of a snarky one. Yeah, so this technology here, it's emerging trend. I know that Signify is working right now on creating actual LiFi systems. It is still expensive. It's still a little shoddy. I know Signify system, the light does not have to be on, which is which was in the development phase, one of the major caveats of the system. But at this point, it's still going to be expensive, prohibitive, and it's such new technology that before implementing, I'd let it kind of stutter a little bit beforehand. But keep your eye on it. If you're going to be at something like a light fair, check out the Signify booth and some of the other players. And again, it's constantly evolving. It's been fun to see every year another piece of the puzzle fall into place there. All right, so that was the only question I had was about the LiFi right there. Again, in that case, I'll slowly talk my way off in case there's any last questions that emerge. But again, thank you so much for attending. And again, this is for webinars. If there's any way that as a firm we can help with any lighting design specification, please let us know. That's our bread and butter. It's what we do and what we offer. So we're happy to go get involved and take that off your plate, or at least assist and work together on creating modern lighting designs for schools and high traffic facilities. All right, then in that case, that's that. Have a beautiful rest of your Wednesday, rest of your week, and hopefully an even better weekend. All right, thanks again, everyone. Be well, stay safe.